Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad Redzuan bin Ismail from BMMA section 1/1. This is my personal background and my supervisor is Dr. Najia Safwa. So, my title for my research project is Bathymetric study at the Malacca River using compressed high intensity radiated pulse device. So, Uh, for my research overview, I will do a hydrographic survey on the riverbed of the Malacca River by using deeper smart sonar device. So this is the device that I will use for my research. And the next is problem statement. The first one is no bathymetry study done that map or mapping the depth and shape of underwater terrain to illustrate the land lies below for Malacca River. So for the next problem statement is the location of the shallow river depth point that could present significant risk of boat accident is still unknown. So for the project objective, the first one is to perform hydrographic survey on the riverbed of Malacca River by using the CHIRP device. And the second one is to study the functionality of the CHIRP device, whether it is helping to conduct a bathymetry study or not. So my project scope is to find out the accuracy of the deeper smart sonar CHIRP device. And the second one is the project scope only focusing on the Malacca River. So for my literature review, I have found a lot of literature that I review in my research paper. First one is Malacca River, the second one is pollution, the third one is bathymetric, the fourth one is compressed high intensity radiated pulse. But I will explain about the literature review about bathymetry. So bathymetry is used for monitoring, predicting port facility, dredging, topography, and navigation. So this is the usage for bathymetry study or bathymetric study. The next one is compressed high intensity radiated pulse. So this pulse has three type of techniques or three type of techniques, and the first one is compressed high intensity radiated pulse compression. The second one is single beam, and the last one is multi beam. So for the methodology for my research project, uh, in this chapter it has data acquisition and data processing, where the data acquisition covers about study area and path planning. For the data processing, it is about the fish deeper application and grading bathymetry data. So the study area is around the Malacca River watershed from Jalan Munshi Abdullah to Jalan Laksamana. And the study area cover around approximately 3.1 kilometer of the Malacca River. So as you can see here, this is the location that I will conduct my research. So the next one is equipment that I use for my research. The first one is remote control boat, Flytech 2011-5, and the scanning device or deeper smart sonar device. So this is two equipment that I use for my research. So this is technical specification for my remote control boat, and my remote control boat has a maximum remote distance about 500 meters without interference. So the next one is technical specification for my scanning device or deeper CHIRP plus device. It has maximum depth around 100 meter with scan rate up to 15 seconds. And this is for my result and discussion. The first one is designing, the second one is data processing, the third one is data analysis, and the last one is discussion. So for designing a mounting clamp, so I have designed the mounting clamp. This mounting clamp is to clamp the board and hold the device so that the device will steady will sit steadily on the water. So this is the process that I do for designing the mounting clamp. The first one is rough sketch, the second one is 3D modeling, and the last one is my final product. So for the next one is data processing. I use Fish Deeper application for my data processing. As you can see here, it is available on App Store and Play Store. So the function of this application, it can translate or it can transform the data from the device uh, and it can illustrate the depression contour in our phone. So the next one is about data processing tool. So based on the Fish Deeper application, this is the scan history of the scanning process, and the data obtained, it will look like this. So for data analysis, the data is separated into 10 critical points of the river. The depth of the river determines the point. So this is the location of scanning process that I already done for my research. So the data component consists four components. The first one is the surface of the water, and the second one is water level or depth of the river. And as you can see here, the green green color or green one is the river aquatic plants, and the brownish thing is underwater sediment. So based on this data components, we know that the water level depth, the river aquatic, and the underwater sediment. Other than that, the deeper application also generates a contour map from the data obtained. So as you can see here, uh, this application display a basic contour map from the scanning process, but you can see here the contour line here, and the contour line is indicate the relative slope of the underwater terrain. So this is the example of contour map obtained from the deeper application. So as you can see here, this is the data obtained from the scanning process. As I said before, I already separate the point into 10 different critical points. So this is the data obtained. This is the data looks like in the application that I use for my research. So this is the first point, second point, third point, and fourth point. This is the fifth point, sixth point, the seventh point, the eighth point, and the ninth point, and the last one is the 10th point. So for my discussion, the total scan area has covered about 534 meter of the river. The deeper application will project the resulting scanning from the device. So the research data obtained from the study will be given to Perbadanan Pembangunan Sungai dan Pantai Malacca for future development for Malacca River. So the agency should be alert to the river depth since it is a tourist attraction used for river cruise activity. And based on my scanning process, there are some shallow points might be danger to the tourists cruising on the boat because every boat has a minimum depth for the boat to float on the water. So aside from helping the agency, this research also allows the researcher or inventor to create a new product or invent a new product to put or to use for improving the river water quality. So maybe the inventor need to know the depth of the water, or maybe the inventor needs to know where to put their product. So my research will help them to determine which point they can put their product. So throughout this project, the deeper application has become fundamental for storing the data from the scanning process. So the software or the deeper application help to create, produce, and project the structure of the underwater sediment scanned by the sonar device. So the device works perfectly with the deeper application because it helps me to collect the data for bathymetric study. The shallow river depth could present a significant risk of boat accident. Next is the device is proven. The device functionality is proven by the data that I obtained in the deeper software. So we can use the device to scan the area very well. So the last one is recommendation and restriction. The first recommendation to make the project better for future development, you need to select the point or critical point before starting the scanning process. And the next one is you need a water level sensor that can determine the actual depth of the river in order to find out the scanning device is accurate or not. So the next one is the device needs a good signal to operate well. So if your phone did not have a good signal, the device cannot detect the GPS. So the last one is use a high power remote control boat because river current because if the river current stronger than your remote control boat, your boat will not, your boat cannot fight against the current. So the restriction is my mounting clamp is wobbling during the scanning process, the COVID-19, and my phone has low signal during the scanning process. So that's all the recommendation and restriction from me, and that's all from me. Thank you.